Now introduce Gaussian elimination. Given a 3 by 3 linear system, we can express it in coefficient matrix form. We did this in Algebra 2. The corresponding augmented matrix will be written as follows. For this augmented matrix, we will perform Gaussian elimination. You are performing a sequence of elementary row operations. You can exchange any two rows, or multiply a row by a non-zero constant, or add a multiple of one row to another row. Then you can get echelon form like this, or reduce the row echelon form like this. In this way, you can figure out the solution to this system of equations. After you did Gaussian elimination, one solution you will get this form, means the three planes intersect at a point. The third row means 0x plus 0y plus, let's use nz equals m. We can use this equation to solve for z. Then plug back into the second and the first row to figure out x and y. In this case, three planes intersect at a point. If you get this form, means no solution, because 0x plus 0y plus 0z equals n. N is not equal to 0. This equation is always false. So no solution means no common point for these three planes. If you get this form, 0x plus 0y plus 0z equals 0. Since this equation is always true, it means infinite solutions to this system of equation. So the three planes intersect in a line. Make z equals lambda. Then you can solve x and y in terms of lambda to figure out a vector equation of this line. Here are some rules for Gaussian elimination. When one row of the matrix is changed into one of these three forms, stop doing Gaussian elimination, because you can work out one variable easily. For this pattern, you can work out z easily, because you have 0x plus 0y. For this pattern, you can work out y, because you have 0x plus 0z. For this pattern, you can work out x, because you have 0y plus 0z. When one of the rows of matrix changed into this pattern, means 0x plus 0y plus 0z equals star, means no unique solution. When star equals 0, this is always true. So there are infinite solutions to the system of equations. The three planes intersect in a line. When star is not equal to 0, means this equation is always false. No solution to this system of equations. The three planes has no common point. For example, consider the following system of equations where A is real numbers. Find the value of A for which the system of equations doesn't have a unique solution. Doesn't have a unique solution, which means we need 0, 0, 0 for one row of the augmented matrix. Therefore, we need to change this system of equations into augmented matrix form. Let's label row 1, row 2, row 3. The first step, we try to make this number equal to 1. We can exchange row 1 and row 2. We get 1, 2, A, 5, 2, 4, negative 1, 10, 5, 12, 0 to 8. Next step, we try to make this into 0. 4, 5, 6. Row 4 times negative 2. Then add 5. Go to row 5. Negative 2, negative 4, negative 2a, negative 10. Row 4 still stay 1, 2, a5. Negative 2, add 2, 0. Negative 4, add 4, 0. Negative 2a, add negative 1. Negative 2a minus 1. Negative 10, add 10, 0. 5, 12, 0 to 8. We try to find the value of A for which the system of equations doesn't have a unique solution. We need 3 zeros in one row, which means we will make negative 2a minus 1 equals 0. A equals negative 1/2. So when A equals negative 1/2, the system of equations doesn't have a unique solution. Let's go to B. Find the solution of the system of equation when A equals 2. Let's take advantage of the augmented matrix form of system of equations. For the second row, 0x plus 0y plus negative 2 times 2 minus 1z equals 0. Negative 5z equals 0. Z equals 0. Then we will use the first row of this matrix. 1x plus 2y plus 2a equals 2, z equals 5. Since z equals 0, we have x plus 2y equals 5. From the third row of this matrix, 5x plus 12y plus 0z equals 2 times 2 is 4. We get 5x plus 12y equals 4. So these two equations will form a system. X plus 2y equals 5. 5x plus 12y equals 4. Let's label equation 6, equation 7. I can change equation 6 into x equals 5 minus 2y. We can solve this system of equations by substitution. 5 times 5 minus 2y plus 12y equals 4. 25 minus 10y plus 12y equals 4. Combine like terms, 25 plus 2y equals 4. Minus 25 both sides. Y equals negative 21 over 2. So x equals 5 minus 2 times negative 21 over 2 equals 26. The solution to this system equation is 26, negative 21 over 2, 0.